DNA polymerase comes, removes DNA if it's a mistake, and will chop it off and place the new strands there. And always ligase is involved. So just know that repair happens that way. All right. I'm going to start by telling you guys about gene expression, but again, slowly. So next week, Monday, hopefully we'll finish chapter 8. But again, let me introduce the process of gene expression and some of the important things that are there. Questions about this? I know I'm starting with gene expression, but what I want you guys to do is for chapter 8, start studying for it now. First, forget about gene expression. Know replication and know it very well. You are just master of DNA replication. Because when you study them together, students mix the whole process together. The process of replication requires a lot of enzymes. Gene expression is one enzyme, and then ribosomes, and tRNA, rRNA, and all of that. Okay, Inga, sorry.
I wanted to verify for the replication forks, there are 2 helicases, and they each go opposite directions.
Yes, so you have a replication bubble with 2 forks.
Gotcha. So
Yeah.
they have their own sets of the polymerases.
Exactly, constantly coming and going. All right, gene expression. Reminding you guys, we kind of talked about this process. So genes are segments on your chromosomes that have the information for a specific protein. Your chromosome is made up of DNA. So another way of putting it is a specific sequence on your DNA has the information or recipe for making a specific protein. When that protein is made, then that protein goes and has an effect in your cell. That's how DNA commands you. Its genes is expressed and does something in your cell. All right, that's the function of DNA. So genes you kind of know. In the process of expression, gene expression, so DNA, as you can see, even from DNA polymerases, DNA is one of your most important molecules in your cell. So you cannot randomly allow things to come and look at DNA, get involved with DNA, and use DNA. Because they can make a mistake, they can cut DNA, they can damage DNA. So you don't want that to happen, and DNA is constantly being expressed. So you again have to use specific enzymes that know how to deal with DNA. For that reason, it's kind of like having a blueprint for a specific, like the original blueprint that made the first iPhone. That is held at a vault. When they want to make iPhone, they're gonna actually send copies of that blueprint, which they don't do it all at once. They take one piece and send it to this country, another piece, so you don't see the whole thing together, right? Espionage. Gene expression is kind of like espionage too. So you have your gene, that's the ultimate recipe. That's the recipe that has been passed down generation from generation. So that great-great-great-great-great-grandmother's recipe, the holder of that recipe is not going to say, you want grandmother's pumpkin pie? Here, take the recipe, go. I'll see you in 3 weeks, hopefully. No, they're going to be like, I make a photocopy of it, you take the photocopy. Because if you lose this thing, or if you damage it, we're all done. We no longer can make great-grandmother's pumpkin pie, all right? So it's kind of like espionage. Think about it, again, the same thing. Give all of the enzymes, when you're working, give them a face. See them working and doing these things. Make silly examples for yourself. That's how you see the process happening. When you see the process happening, moving in your head, I promise you, nobody can take it away from you. So here, the same concept. DNA is the main recipe. it can't let ribosome, tRNA, amino acids, and everything come to the nucleus, for example, for us, and deal with it. Same thing with the bacteria. If one of them cuts DNA, we're done. That cell dies. So we can't do that. So the process of gene expression has 2 steps. First, a specific enzyme knows DNA, goes and reads that sequence and makes a transcript of it, a copy of it. It's in form of RNA. Why? Because, again, DNA polymerases need a 3' and all of that. RNA polymerases are like, okay, it's an A, I'll put a U. It's a T, I'll put an A. It's a C, I'll put a G. They don't care. They can start anywhere and make a strand complementary to what they're reading. So that's how it basically has to go. First, it transcribes. Then that secret comes back into the cytoplasm, or for bacteria, it is already in the cytoplasm. The job of translating nucleic acid, nucleotide bases into amino acid order belongs to ribosomes and tRNA. They read the RNA and they go, oh, it says this word. It means this amino acid, so put it here. The next amino acid is that, so they translate. They take nucleic acid language and they make it into amino acid language. So transcribe, translate. Good? All right. We have